In this video, I'm going to show you how to prove the derivative of x to the power n, which is equal to nx to the power n minus 1. First, let's review how to find the gradient of a line in a Cartesian graph. Let's try a straight line. Name it as fx. Let's put two different points in the graph. Let's name it as x1, x2, and the respective y coordinates, y2, y1. To find the gradient in a straight line, we simply use the equation, the difference between the y coordinates by over the difference between the respective x coordinates. We can also write x2 minus x1 as some difference. Let's name it as h. Therefore, you can write x2 as x1 plus h. So we can word the gradient equation in a different way. Since we have the function fx, we can write y2 as fx1 plus h, y1 as fx1, and therefore m can be written as fx1 plus h minus fx1 x1 plus h minus x1. Now imagine we are working with a curve instead of a straight line. We know that the gradient of the curve would not be the same at every point of the curve. So how do we figure this out? Let's put a straight line on any point of the curve. So here, we'll choose two different points and name it as x1 and x2, and the respective y coordinates as y1 and y2. From earlier, we know that the gradient of a straight line is fx plus h minus fx by x plus h minus x. However, since this is a curve, we cannot really get an accurate answer for the gradient of the curve. So we need the difference between the two points x2 and x1 very small so that it actually approaches to 0. So we can write it as the gradient or the derivative of the curve as the limit h approaches 0, the difference between the y coordinates over the difference between the x coordinates. So from the equation that we have known before, x to the power n, we simply put it in the equation as h approaches 0, x plus h to the power n minus x to the power n over h. Now, to solve this equation, you need to know about binomial expansion, which is a plus b to the power n is equals to, and choose 0, a to the power n, b to the power 0, plus and choose 1, a to the power n minus 1, b to the power 1, up to the nth term, n choose n, a to the power 0, b to the power n. Now we will simply apply this equation here, and then we get n choose 0 for n is to the power 0, n choose 1 is to the power n minus 1 is to the power 1 plus and so on up to the nth term, n choose n is to the power 0 is to the power n, and then we have this term x to the power n minus x to the power n over h. Now, to simplify this expression, we have n choose 0, which is 1. Then we have h to the power 0, which is also 1. So we only are left by h to the power n. Plus we have n choose 1, which is n. We have h to the power n minus 1 times h. And then we don't have to worry about the rest of the terms, as it is very much repetitive and not required for us for the rest of the equation. You'll understand it later as we go on. And then we have the last term, which is h to the power n, as x to the power 0 is 1, and n choose n is also 1. And then we have minus x to the power n over h. X to the power n cancels out, and then we have h. So h cancels out, and the rest of the terms also has h to it. So the final remainder expression we have is nx to the power n minus 1 plus all the terms in terms of h. And since we have this condition as h approaches 0, the rest of the term will be 0, and then we are only left with nx to the power n minus 1. That's it. That's how you get the proof of equation to the power n, and the derivative of it is nx to the power n minus 1. Thank you.